All right, so now let's talk about unpacking a file. If you can't identify the packer, you can do it with a debugger, and this is a good thing to know. So we're going to use putty, and I've already got it on these machines. So if I go to my Windows desktop, I think it's probably in the downloads folder. Let me see. Lots and lots of junk in here, including putty. All right. And by the way, you want to check the hash to make sure this is not a modified version of putty, because in some of the projects we are going to modify it. So you run hash calc, and then you can run the hash of putty, and the right answer should start with BA7, and it does start with BA7 for the MD5 hash. So this is the clean, unmodified version of putty. Oh, that's what I want. Now, I'm just going to put a copy of it on my desktop and work there so I don't mess up the original. So I'll copy and paste. All right, now I got a putty on my desktop. So we launch it, and putty is just a, and I'll just tell it to run it without asking silly questions. All right, and now all we want to do is see that it works. And we're going to see how to compress this file. So here's a working program. All right, so I'll just cancel this. Now I'm going to compress it. So I open a command prompt, and I put it on my desktop. So I cd to desktop. Whoop. All right, and if I do a directory, there's putty. So I want to make a compressed version of putty, and so that's UPX minus, put the output in putty comp. I can't type, mp.exe, and compress putty. That should do it. There. So putty was 500K, and it shrunk it down to 267K. All right. And now I can check the hash value of putty comp, which is here with the same tool. Drag putty comp into there, and the MD5 starts with C66, and that's correct. So there's my compressed file. Now, this file is half the size, but you can run it just the same. If you launch this, it just opens and works the same, which is magic, which is why people like it. It's compressed on the disk, but it unpacks into the same image in memory. And we want to understand how that works. So we'll start with this tool called pestudio. All right. And I'm going to open putty, the one on my desktop. And then I'm going to open another copy of pestudio so I can compare them. And open the compressed file, so it's easy to compare the two next to each other. There's the compressed file. All right. And so, here's the MD5 of the compressed version, which is C66, and of course the MD5 of the original file is different, so that's obvious. Then there is indicators. Indicators are things that pestudio considered to be suspicious. And notice, I'm going to move these instructions out of the way. All right, get this visible. All right, that it considers 56 things suspicious about the original putty, which is not harmful at all. And it considers 44 things suspicious about the compressed one, so that's not very meaningful. That's pretty much false positives. And then there's virus total, which the original file has 0 hits. The compressed version has 9 hits out of 69. Now we know it's not malicious, but just the fact that it's packed is flagged as suspicious by some engines at virus total. So, you know, it's that's really, I'd regard that as a false positive too. Now, let's look at the sections. If you expand this, well, here you see the sections. These are the normal sections you see in a normal Windows executable: text, rdata, data, and resource, RSRC. But as we saw before, if you look at the sections in a compressed file, you have UPX0, UPX0, UPX1, and the resource section is not compressed, which is, by the way, a mistake by the developer. of the program UPX. They meant to compress it but failed, so the resource section is actually unaltered. Anyway, all right. You can also see permissions. The text section is not writable but executable. This is really important. A classic buffer overflow involves putting executable code in a field like a password. That's a field that should be writable but not executable. And in a classic buffer overflow, you inject executable code where text should go, and then you execute it. And in order to prevent that, all modern operating systems make an attempt to enforce this rule, W or X. Every memory section should be writable or executable, but never both. And so the text section is the executable code, so it's not writable. It cannot be altered while the program is running. And the data section, where you put in like user input, is writable but not executable. This is a good practice. And you can see down here that the UPX0 is both writable and executable, and so is UPX1, and it turns it red because that's suspicious. That is not normal for an executable code. That's something that really shouldn't be done. It's not a good practice. Another interesting number is the entropy, which is here. Text is assembly code. It's almost random. Completely random would have an entropy of 8, where all 8 bits are used. So 6.7 is pretty high. This is almost completely random, and the resource data is pretty random. The other data is very low entropy, 2.4, because that probably contains ASCII text, normal strings, and they don't really use all 8 bits. As you probably know, there are only 7 bits are used by ASCII, and in fact, they're not all equally likely to be used, so that could be compressed, and this resource is in between. These have unused space in the bytes. The bytes are not exploring all possible random values, so these could be compressed. That's what that's indicating with low entropy. Whereas here, if you look at the entropy, this section actually starts with a size of 0 bytes. It's just an empty placeholder at first. All the data is here in the UPX1 section, and its entropy is 7.9, which is almost perfect 8. So what's going on with the UPX packer is it's taken all the data and it's packed it and compressed it into this one section, and then the loader will unpack it and create these sections in memory. So that's what's happening. All right. And now we're going to look at these sections in PutyComp. There's also an entry point here, which is here, highlighted 860E0. We're going to see that a little later. All right, now we can check the imports. In the original Putty, here's the imports, which are Windows libraries it uses. And you see this is a relatively simple program, and yet you see it has an awful lot of imports, about 4 screens full of Microsoft Windows system functions it uses. But PutyComp has a very short list of imports, only like 12 or 15 compared to the page after page, because you're not seeing the Putty. All you're seeing is the unpacker. And the unpacker is an even simpler program that just unzips the sections. All right. So then there's a flag defined. All right, now we're going to try to unpack this stuff in a debugger. Now that we've got a simple program to debug, we're going to use the famous old program OllyDbg, which is one loved by Windows hackers for years to cheat on Windows games and so on. The only problem with OllyDbg is it only works on 32-bit software. There is a modern program called X64Debug that's very similar, that works on 64-bit program, but we're going to use the old-fashioned OllyDbg here. So we're going to open normal Putty here off the desktop. And somewhere here is Putty. There it is. All right. And now I'm going to launch a second instance of OllyDbg to open the compressed version. Okay. All right. Now, if we look at the original, now I get a warning here. Quick statistical test of module PutyCom reports that its code section is compressed, encrypted, or something. Do I want to continue? I'll say no. OllyDbg notices that something is strange about that compressed program. All right. So here, notice that it starts putty.exe. This putty compressed starts at this address, 486.0E0. Now what a debugger does is it loads the program into memory, just like it would any program, so you can run it, and then it stops it from running. It pauses it so you can examine it and modify it. So the code is ready to run. This is the assembly code, and here's the entry point, and it's not running. In the corner, it'll tell me it's paused. So this is the compressed version, starting at 486.0E0. The uncompressed version is here. And see, that starts at 4550F0. The entry point is different in the compressed version. All right. And the original program starts with push 60 and then push putty something. But the compressed version starts with push add and then move. This code is different because what you're seeing is not putty, it's the decompressor. Now, if you view the memory map of the original putty program, here you can see the memories being used by it. View memory. And here are there's other sections being used by things like libraries, but here's the putty memory sections. All Windows programs like to load at 400,000, that's where they like to be. And so putty is here, and then there's a text, RData, data, and resource sections. And those are the memory regions used by putty. If you look at the compressed version, here, view memory, here's putty compressed, also loading at 400,000, but it's UPX0, UPX1, and .resource. Quite different, as we've seen before. All right, now we can dump these sections. So let me go to the original putty, and let's look at the text section, which contains code, and dump it. And here you see it's readable code. It disassembles it, and here's the commands that it's going to execute when this section runs. All right. But if I go to the UPX section and dump it, it's just full of zeros. There's nothing here, because that's where it's going to put the uncompressed stuff. If you look at the UPX1 section and dump it, that's got what it's interpreting as executable instructions, but it's got an error here. It's not really executable instructions. It's compressed data. All right. We've done this. All right, that's good enough for that. Now we're going to view the unpacking stub. So let me get back to the putty compressed. Okay, so here's the code. Now if I just jump through this code with page down, there's really not very much code here. If you just go down a few pages, you don't even have to read or understand the assembly code too much. There's a bunch of assembly code instructions, but after just a few pages, it's going to stop. Now it's all just zeros. That's it. The code up to this jump, that is the unpacker. That is the only part UPX added. There's not very much to it at all. And that means we can do the we can analyze this by running the unpacker and then stopping. This is what you use a debugger for. So what I want to do is stop on this jump command, and you do that with F2. You can also do it by right-clicking or by using one of these menus to put a breakpoint there. So the red means a breakpoint. Now I can run the program and it will stop at this point. So to run it, you can run it with the run button here or press F9. The program is currently paused. I hit run. It runs and stops here at this point. And it tells you breakpoint at that address down there. So it has run this part. Now I'm going to press the F7 key to execute one more instruction. And notice it's now jumping somewhere, 4550F0. If I execute one more command, now it has moved to 4550F0. And notice this is push 60, push putty com. That might look familiar because that is now the original putty. If you look at the original putty here, it was push 60, push putty com, and so on. That's what I did by running that first block of code was decompress the compressed data and load it in memory, and now it's just the original putty unmodified, ready to run in memory. So that just did the unpacking. And you can run it in OllyDbg, the uncompressed code here, but you can also create an exe file with this tool called OllyDump. So we've got it. It's plugins, OllyDump, and dump debugged process. You run the debugger, you run the compressed version until it creates the decompressed program, and now you just have to make sure it's going to find the right starting point. The right starting point is 4550F0. The start address is 400,000, and the offset here is 550F0, so it's working. Those are correct now. And when they're correct, you can just hit dump. And now you can save a dumped version of it, puttydumps.exe. All right. All right, and now I think we're done with OllyDbg. I'll close these OllyDbg windows. There's putty dumped, and I can examine that in pestudio. All right, and now the imports section, for example, is still loading. But it shouldn't take too long to do it. And what we're going to see is that the import section is much bigger than before. Remember, there are only like 14 imports in the compressed version. It's now going to be almost back to normal, although not perfect. When I did this process did not fully create an exact identical to the original one. But it, anyway, that's what I wanted to show you here, the manual unzipping. So I'm going to stop this video.